Chemistry is the study of the composition, structure and properties of matter, and the reactions by which one form of matter may be produced or converted into other forms. Dear students, all the objects in the universe are made up of matter, since they occupy space and have mass. Matter is classified into two types of substances: pure substances and impure substances. Pure substances comprise of elements and compounds, whereas impure substances are mixtures. Mixtures are formed by the combination of two or more than two kinds of matter, which can be separated by physical means, whereas both element and compounds are pure substances and they are made up of atoms and molecules. What are atoms? An atom is a smallest particle of an element that can enter into a chemical combination. Only elements like inert gases, for example neon, argon, they do not enter into a chemical reaction because they have complete outermost shells, whereas atoms of other elements do combine with each other and with the atoms of other elements to form molecules. What are molecules? A molecule is the smallest particle of an element or a compound that can have stable independent existence. A molecule may consist of a single atom, as in case of helium, or two or more than two identical atoms, as in hydrogen, oxygen and sulfur, or two or more than two different kinds of atoms, as in water. What binds the atoms together in a molecule? It's a chemical bond. A chemical bond is the net attractive force that holds two adjacent atoms together in a molecule. Hydrogen molecule is composed of two hydrogen atoms. Water molecule is composed of two hydrogen atoms and one oxygen atoms. On the other hand, in solid sodium chloride, molecules are not there. Rather, sodium ions and chloride ions are arranged in a definite pattern in a crystal. What do we say then? The simplest ratio of sodium ions and chloride ions in a crystal is termed as formula unit. Today we will discuss how are atoms held together, why do they have shape and properties, how are electrons distributed among atoms in a molecule, and why is the hydrogen molecule hydrogen, that is H2, not H3 or H4. Atoms of inert gases have stable electronic configuration. They have complete outermost shells. Therefore, they do not participate in a chemical reaction. Whereas atoms of other elements, they tend to acquire the configuration of inert gases and they gain or lose electrons for this purpose. Let's see what is the electronic configuration in case of helium and neon. Helium is an inert gas, atomic number 2. The electronic configuration is 1s2, that is 2 electrons in its valence shell. Neon, atomic number 10, the electronic configuration is 1s2, 2s2, 2p6. You can see from this model the 2 electrons in the first shell and 8 electrons in the outermost shell. Therefore, it has a complete octet. Atoms of other elements, they tend to acquire the nearest noble gas configuration, and this is the cause of a chemical change. What happens when two atoms come together? Dear students, every physical system tries to go from higher energy state to lower energy state. When the two atoms come closer, they interact with each other As a result of this interaction, bond is formed, and this lowers down the energy of the system. In an isolated atom, each electron is under the influence of its nucleus. But when the two atoms come closer, electrons of one atom are influenced by the nucleus and electrons of the other atom, and interaction takes place. This interaction gives rise to the attractive force between the two, and bond is formed. This can be shown with the help of a graph which has been plotted between the potential energy of the system against the internuclear distance r. This is the graph which has been plotted between the energy and the internuclear distance r. If we have two atoms, then there will be two possibilities for them. One is that when they come closer to each other, the repulsion between these two atoms increases the energy of the system, and they will tend to move as far apart as possible. This can be shown by this curve A, which is repulsive interaction. Another possibility is when these two atoms they come closer and the internuclear distance decreases. What happens? At equilibrium distance RE, bond is formed and the energy of the system is lowered down. But as the internuclear distance increases, there is a sharp increase in the energy, which can be shown by this curve B, which is representing attractive interaction between the two atoms. Dear students, now you have come to know how a bond is formed. There are three types of bonds there: ionic bond, covalent bond, and coordinate covalent bond. Let's discuss ionic bonds first. Dear students, as you know that some atoms have low ionization potential. They can lose electrons readily, whereas some atoms of the elements they have high electron affinities and they can accept electrons readily. Ionic bond can be formed between these two types of atoms. So, how will we define an ionic bond? The bond formed by the complete transference of one or more electrons from one atom to another atom is called ionic or electrovalent bond. Atoms of elements which have low ionization potential, they lose electrons which are picked up by the atoms of the elements which have high electron affinities. We can show it with the help of an example, and we have an example of sodium chloride here. This is the periodic table in which elements are arranged in horizontal rows and in vertical columns. Horizontal rows are known as periods and vertical columns are known as groups. Metals are present on the left side of the periodic table and they have low ionization energies. For example, the elements of group 1A, lithium, sodium, potassium, rubidium, cesium, they have low ionization energies and they can lose electrons readily, forming ionic bond. Some of the metals from group 2A also form ionic bond easily. Whereas elements present on the right of the periodic table, for example, nitrogen, oxygen, sulfur, they can form ionic bond easily by picking up electrons from these metal atoms. Consider an example of sodium chloride. Sodium belongs to group 1A of the periodic table. It is a metal. It has low ionization potential, so it can give up electron more readily, forming cation. Whereas chlorine belongs to group 7A of the periodic table. It has high electron affinity. It can pick up electron readily, thus these two can form ionic bond. Let me explain it to you. Sodium here, atomic number 11, The configuration is 1s2, 2s2, 2p6, 3s1. It is having one electron in its valence shell. Chlorine, atomic number 17, configuration is 1s2, 2s2, 2p6, 3s2, 3p5. It has 7 electrons in its valence shell. How will a cation form? Sodium, if it has 1 electron, by losing this 1 electron, it will acquire nearest noble gas configuration, that is of helium. In doing so, the energy which is required is equal to 496 kilojoules per mole. Chlorine forms anion by gaining 1 electron. By picking up 1 electron from sodium, it acquires the configuration of argon. In doing so, the energy which is released is equal to 349 kilojoules per mole. Thus, we have sodium ion and chloride ion. When they combine, the attractive force which binds them together is electrostatic in nature, and it is a very strong force. The energy which is released during this process is equal to 787 kilojoules per mole. You can see that this energy is more than to compensate the difference in energy between step 1 and step 2. So, total decrease in energy of the system is equal to 640 kilojoules per mole, which is released during the formation of sodium chloride. When sodium and chloride ions are formed, they are held together by strong electrostatic force of attraction and arrange themselves in a definite pattern in the crystal lattice. Thus we get a solid. We have other examples of ionic compounds also. For example, calcium chloride, sodium sulfide, etc. All these compounds which are formed through ionic bond are very stable. So, let us discuss some characteristics of ionic compounds. Number 1, most of the ionic compounds are solid at room temperature. Number 2, ionic compounds have high melting and boiling points. Number 3, ionic compounds are soluble in polar solvents like water. Number 4, ionic compounds dissociate when dissolved in water and conduct electricity in molten or dissolved state, however, are non-conductor in solid state. Number 5, the crystals of ionic compounds are made up of ions. Number 6, the reaction between ionic compounds are usually very fast. Many compounds do not form by the formation of ions. Instead, atoms are tightly bound together in these compounds. These compounds are formed through covalent bond. So, what a covalent bond is? A bond which is formed by the mutual sharing of electrons between two atoms is called a covalent bond. The simplest example is of hydrogen molecule. You know that hydrogen has 1 electron and each atom shares this 1 electron with the other. This mutual sharing of electron pair results covalent bond between the two atoms. This can be shown by an equation. These are two hydrogen atoms having 1 electron in each of their valence shell. When they come closer, they form covalent bond by the mutual sharing of this electron pair. The energy released during this process is equal to 435 kilojoules per mole, and equal amount of energy is required to break this bond. This bond is formed by the mutual sharing of 1 electron pair. Therefore, it can be represented by this short line. There are other examples of covalent compounds also, and such type of compounds are formed when atoms of non-metals combine with each other. Such type of bond is formed between the atoms of the elements belong to group 4, 5, 6 and 7 of the periodic table. Single covalent bond is formed when two chlorine atoms come closer. They share one pair of electrons mutually. Thus, a single covalent bond is formed. This can be represented by this short line. Carbon tetrachloride is another example in which carbon shares its 4 electrons with the 4 chlorine atoms, thus forming a covalent compound. Oxygen forms double covalent bond with another oxygen atom in oxygen molecule. This can be represented by two short lines. Triple covalent bond is formed by the mutual sharing of 3 electron pairs in a nitrogen molecule. It is represented by 3 short lines, as you can see here in the structural formula of nitrogen molecule. Dear students, the distribution of electrons in a molecule can be explained by using two general approaches. Here is Professor Sharif for you to explain these general approaches.
Dear students, let us explain the distribution of electrons in a molecule. The distribution of electrons in a molecule can be explained using two theories. First one is the valence bond theory, which is simpler but less correct. According to the valence bond theory, the atoms in a molecule are very much like isolated atoms, except that one or more electrons from the outer shell of an atom are accommodated in the outer shell of another atom. It uses only orbitals of isolated atom. Second approach is the molecular orbital approach. According to molecular orbital approach, each electron belongs to a molecule as a whole and may move throughout the entire molecule. The spatial distribution of electrons in the molecule are called molecular orbitals and may be considered like orbitals of the isolated atoms. Let us explain these two approaches in more detail. According to the valence bond theory, a covalent bond is formed by the overlap of two atomic orbitals, each having one electron. When the two atomic orbitals combine linearly, the electron density is concentrated in the middle of the two nuclei. Let us see an example. In case of hydrogen, there is one electron in its 1s orbital, which is spherically symmetrical, and the electron charge is distributed around the nucleus. Same way in the other atom of the hydrogen atom, the electron charge is distributed around the nucleus. The two atoms combine together to make a molecular orbital in which the total charge density is concentrated between the two nuclei, and the line joining the two nuclei, the total charge density lies in between or along this line of axis. So, this way a bond that is formed is a strong bond. They overlap in a linear manner to form a sigma bond. Similarly, a bond between hydrogen and fluorine is a sigma bond and can be explained. Hydrogen has 1 electron in its s orbital, fluorine has 7 electrons in its outer shell. The 7th electron, the unpaired electron, is in 2px. The charge density of fluorine is in the 2px, charge density of hydrogen is around its nucleus in the 1s orbital. When 1s orbital of hydrogen approaches the px orbital of 2px orbital of fluorine, the s orbital of hydrogen and p orbital of fluorine, they overlap in a linear manner to form a sigma bond. The charge density is lying between hydrogen and fluorine atom, and in this way a strong sigma bond is formed. Now, let us look at the example of a hydrogen molecule, which is the simplest of all. The s orbital of atomic orbital of one atom of hydrogen and the s atomic orbital of other atom of the hydrogen, when they approach each other after approaching, they are then making two molecular orbitals. One of them is lower in energy than the atomic orbitals and is called the bonding molecular orbitals. The other one is higher in energy than the combining atomic orbitals and is called anti-bonding molecular orbitals.
Dear students, let's sum up today's lesson. An atom is the smallest particle of an element that can enter into a chemical combination. A molecule is the smallest particle of an element or a compound that can have stable independent existence. A chemical bond is the net attractive force that holds two adjacent atoms together within a molecule. A molecule after bond formation is in lower energy state than an isolated atom, which gives it stability. A covalent bond formation can be explained using two methods, valence bond method and molecular orbital method. Dear students, this was all about chemical bonding. We shall see you in the next program. Till then, Allah Hafiz.